Hey guys, welcome back to the channel. So today we would be solving the first problem of weekly contest 463. It's time to buy and sell stock using strategy. So this is a medium tagged problem. So generally the problem first of any of the weekly or bi-weekly contest, it's easy. 90 to 95% of the times the problem is easy. But this one is medium, and I think it is actually a medium problem, easy medium I would say. So we are given two arrays, prices and strategy, and we are given an integer k. Okay, so this prices denotes the stock prices at a particular day, and the strategy contains three values, basically -1, 0 and 1. And one says that we can buy a stock, and this is we hold a stock, and this is we sell a stock. Okay, so we have prices and strategy, and we have to trade the stocks based on the strategy on each of the days, and at the end we get some profit. Let's say, so if we trade the stocks on each of these days, then it would be P of I into S of I, which is the price on that day into strategy on that day, and we have to do the summation of this for all the days. So this will give us some profit or some loss. Okay, and then we are also given this value k. So this is always a even number. We are always given an even number here. And what we can do is we can select any subarray of this strategy of size k. Here k is 4. So let's say we select this subarray, and what we can do is for half of the elements we will make them 0 for the starting elements, like the starting half elements, and for the remaining elements we set the strategy as 1. So this is a fixed pattern which we have to do for this subarray, and after this modification we can again calculate the profit across all the days by considering these new values for this subarray. So it would be something like 3 into 0 plus 1 into 0 plus 2 into -1 plus 4 into 1 plus 6 into 1, because here we are not modifying anything, and again here it would be 2 into -1, because the same case we are not modifying anything here. Okay, now we can choose any subarray of size k from this strategy, and we have to make it 0 0 and 1 1, like the first half elements should be 0 and the next half elements should be 1, and we have to calculate the profit of all the days. And what we have to do is we have to maximize the profit across all these operations. So it is possible to not select any of the subarray from this S and modify it, or we can select this first subarray of size 4, or let's say this second subarray, or let's say this third subarray. Okay, so you are getting the gist, right? So whenever we get this kind of problems, the first obvious thing that we can do is generate all the subarrays. Let's try to see the naive solution for this. So now let's consider that we don't choose any of the subarray and we didn't do any modification. So the simple answer would be the multiplication of all these values, right? The price at that day into the strategy, similarly the price into strategy, and we do this for all the values, and in such a way we can calculate the answer without modifying any of the subarray. Now let's say we select a subarray. Now let's consider some subarray which is starting from here, and it is spanned up to k places. And then what we can do is we can maintain two nested loops. First one, which will be the starting position of this inner subarray, and we will start iterating from the beginning, and then in the inner for loop we will contain two loops, one which will calculate the subarray starting from here up to k places, and in this subarray it will not consider this half elements, because the prices here will not have any significance as we are adding 0 here. So anyways 0 multiplied by anything would be 0, so this will not be considered. and from the next for the next half parts we will just consider the prices, because we will be replacing these elements by 1, which means that these numbers will not change. Okay, so in our nested loop we know that we got this k, and then we will contain another loop at the same level which will calculate the elements which are not included in this subarray, and for these elements it will just consider this normal strategy into price calculation. So it would be something like, let's say, this for loop, outer for loop, it will go from 0 to, let's say, till I plus k is less than n, and we can do simply I plus plus, and then it will have two loops. One is the for loop from this I to up to I plus k, and for this I plus k by 2, like for the half elements we will anyways do p of I into 0, so this will become 0, so we can just neglect this. Also for this second half part we will just consider p of I into 1, somewhat like this, and in the same level we will have another for loop. I'll just shift this. Okay, and here we will have another for loop in the same level, and we will go to 0 to n, and then what we can do is we will calculate simply pi into si, but for all the elements except this subarray, like except the elements which are included in this subarray, so it would be nearly n square. So yeah, in the worst case it would be n square, but can we do better? Is there a scope? Let's try to find what repeating work we are doing. So I'll just quickly erase this stuff. Okay, so let's say initially we consider this subarray. Then we know that for this half elements it will be 0 and this will be 1. Okay, and we will calculate the sum of this part, and here we are not calculating any sum because here there are no elements. Okay, now in this subarray we are calculating this part as 0 because this will not have any effect, and for this part we are simply taking the prices here. Great, now for this we know the answer. Now let's say we extend this array further. Now the subarray is something like this. We exclude this part and we came here, and then we included this part so that our subarray will be of size k. Okay, so what we actually did, so we moved our subarray in the forward direction, and accordingly we will make changes in the inside, like now this will be 0, this will be 0, this will be 1, and this will be 1. So we will not consider our previous values, and again now we know the calculation of this is simply for this first part which is 0, and for the second part we will just take the prices. But interestingly, at the start we will add this -3 into -1, sorry, 3 into -1. We are considering this part, and then the middle one is included in our subarray. Okay, so this is giving me the intuition of sliding window. So one thing is clear, that we can use sliding window. Okay, but how will we make the calculations? Let's try to figure that out. Now let's consider this example. Okay, so we will consider a subarray starting from the start, and it is of size k, and for half of the elements it will be 0, and for next half we will be having 1. Let's say this is the start and this is our k minus 1, or I would say here it is just basically end. Okay, so what we will do is, first we will calculate the answer from start to end, and it would be simply 3 into 0 plus 2 into 0 plus 4 into 1 plus 6 into 1, which is equal to 10. Great. Now for this part we will separately consider the answer, and it would be 1 into minus 1, which is minus 1, and 5 into 0 is 0, so it would be minus 1. Okay, so now for the complete array we have the profit or loss, which is equal to 10 plus minus 1, which is equal to 9. Great. So this is the profit of the array if we consider this subarray starting from S and ending at E. Okay, so let's try to write this answer first. Here our answer is 9. Okay, now let's erase this first. Okay, we will write our S here. Okay, now let's say we move this window ahead. So now the window will start from here and it will end at here. So the S is here and E is here. So what is the first observation that we can make here? So when we slide this window, what are the observations that we can see in the calculation part? First of all, this, which was earlier part of the window, hence it was not calculated in our current addition, and again in this part, this which was calculated in the current addition will not be calculated now because this is now the part of the window. So we will just calculate this part and this part. So our current would be current plus this start position which we got rid of, which is the previous start, or I would say s minus 1, p of s minus 1 into s of s minus 1. Okay, so this is the current start that we calculated, and now as we were previously calculating this part in our current addition, we will just remove this from the current part. So the current becomes current minus p of e minus into s of e. Okay, so we modified our current based on the values which are not considered in this subarray. But what about the values which are considered in the subarray? Okay, so let's try to figure out the observations there. So earlier the second element was 0, but now as this is the first element, it will still be 0. Okay, but now from this one, the first element will get 0 because this is shifted ahead, and for this second element we will add one element here. Okay, because this end is moved ahead, so we will require a 1 here, and since one extra one is added, we will make the starting one as 0. So again we will have our half of the starting element as 0 and half of the ending element as 1. So how will the current change now? So first of all, what we will do is we removed this part. Earlier it was 1, so it was considered, and now it is 0, hence it will not have any significance. So current will be current minus, we have to remove this part. So how we will calculate this? This is simply, as we have our s here, it will be simply s plus k by 2 minus 1. As s is 1, so k by 2 is 2, so 1 plus 2, which will be 3, minus 1 will be 2, which is this index 0 1 2. Okay, so what we'll do is p of s plus k by 2 minus 1 into s of s plus k by 2 minus 1. So s here is basically strategy. This is strategy. Okay, so we converted this 1 to 0, but now let's convert the calculation of this part. So the effect of this on our current would be simply current equal to current plus p of I because here we will make this as 1, hence we will just consider this price part. So we got our answer current. So this group of calculations will give the final value for this window. Okay, so we can keep on doing this and we will calculate the maximum. Like let's say we have some maximum answer as max of this answer or the current value. Here it would be current value. And then at the end we can see that if this value, that is the modification on the original array, is better than the calculation without the array, and the calculation without the array would be simply n minus 1 p of I into s of I. This is better or this is better, and that would be our final answer. Okay, so now let's go to the code and try to see the solution there. So here you can see that first we keep an answer variable and we calculated the length, and then what we do is we calculated this part, that is without any modification on the array, what is the answer. Okay, so we calculated the answer first and then we kept the current variable and we started from the second half of the subarray which we considered, because the first half will always be 0 and that will not have any significance. Hence for the remaining half part we calculated pi into our answer. So this part basically calculates the profit on the array by selecting and calculating answer on the first subarray of size k on the strategy array, and then we will try to see if this our answer is better, like the answer which we calculated without any modification is better than the answer which is calculated by modifying the first subarray from the array. And then we add our sliding window logic here. This is the same stuff that we did here for calculation of our current, just we have one modification here, that if our subarray is of size 2, then each of the half element would be of size 1. So we do this in order to not calculate the current twice for a particular element, hence we do this, and rest is the same. And while moving across the array we keep track of the operation after applying the sliding window, and at the end we'll just return the answer. So yeah, so thanks for watching and subscribe to the channel for more such videos.